All right, one more topic we need to talk about in 2.8 is the graph of a derivative function. So here's the fact that we need. If we graph y equals f of x and y equals f prime of x on the same axes, then for every value of x, the slope of f of x is going to be the same as the y coordinate of f prime. So I want to do several examples for you on here, and then we'll also look at some examples on Desmos. So let's look at this. F of x is absolute value of x. Now we know what that looks like. It's a v. Comes down like this, goes up over there. Now the derivative is the slope. So everywhere over here, the slope of this thing is -1. And over here, the slope is +1. So if we were to graph this, the slope is -1 over here, and then changes to +1. And notice there's an abrupt change here. It doesn't go through, it changes immediately from -1 to 1. So we've got a place here at x equals 0 where the function is not differentiable. All right, let's look at the next one. F of x is x squared, and if you work out the derivative of that, the derivative is 2x. If we graph both of these, f of x looks like this, and then the derivative, 2x, is this. Let me try that one more time. Try to actually hit the origin there. All right, so notice, if you pick any value here, like right here at the origin, the slope of the tangent line to x squared is going to be horizontal, and its slope is 0. So the value of the derivative there is 0. Over here, notice the slope's positive, and it keeps getting bigger and bigger, steeper and steeper. So the derivative, the y-coordinate of the derivative, is going to be positive and keep getting bigger. Over here, the derivative is negative because it's going down, and sure enough, down here the derivative is negative. All right, so what if we're just given a graph like this and we're told to draw the derivative? Well, let's look at it for a second. Any place where we're going uphill on the original function, the derivative is positive. So the derivative is going to be positive here and here. Derivative will be negative when we're going downhill. And at the top and bottom of these, derivative, the tangent is 0, so the derivative is 0. So the way you do this is you draw in the derivative by saying the derivative is 0 here and here. And in between, it's going to be positive over here, negative in between, and then positive over here. Now, there's a question of how do you draw it? Well, I'm just going to draw it in and then I'm going to explain it. It's going to look roughly like that. Notice what happens here with the slope. On the original graph, the slope here is positive. But notice as we get close to this hilltop, the slope, it stays positive until we get right to the top, but it gets less and less steep. So the value of the slope is positive, but it gets close to 0. That's what's going on here. The y value of this is positive, but it's getting closer to 0. And during all of this, the derivative is negative. So we get that. And notice, this looks like a cubic function. If you take the derivative of a cubic function, you get a quadratic function. And that's what this looks like here. All right, let's look at this one. Example 4 here, we've got, this is the original graph, and this is supposed to be 3 straight lines. So remember, any place where you have a sharp corner, the derivative is undefined. So I'm going to put a little line here and one here. These are directly in line with those two corners. And the derivative is undefined here and it's undefined here. Now this is a straight line going down. So we have negative slope here. And then it changes to this. That's also got negative slope, but it's steeper. So it's more negative. So if I were to draw this in, the slope here from here to here, the slope's negative. From here to here, notice there's an abrupt change here from here to there. So the slope is even more negative. And then here it makes an abrupt change to positive slope. So I'm just kind of eyeballing where to put these as far as like how far up or down. But that's what the derivative of this thing would look like. All right, let's look at this one now. This one has a rounded hilltop. And notice over here, it's increasing. The function is increasing, so the slope's positive until you get to that hilltop. So at the hilltop, we've got this. And then over here, it's decreasing. So the derivative is going to be negative on this side. But notice what happens. Let's actually do this half first. Derivative starts off as 0, and then it goes negative, and it gets pretty steep right here for a little bit, and then the derivative kind of levels off. The graph itself levels off to getting a slope that's close to 0, so the derivative is going to do this. And on the other side, the same thing's going to happen, but positive. Down here, the derivative is positive, but very small, very close to 0. And then it's going to get steep for a bit and then go back to 0. So it's going to be positive, and it's going to look roughly like that. Now, on the test, I might ask you to draw something like this, and I'm not going to ask for a ton of detail. The main stuff I want is for it to be positive and negative and 0 and undefined in the correct places. All right, let's look at Desmos for a minute, because Desmos can do this for you. Well, it can't do the drawings for you if you don't have the function, but it can do the derivative of a graph. So let's look at that first one we did. We did f of x is the absolute value of x. Let's pull this down so we can see a good chunk of it. Now on Desmos, as long as you call this f of x or g of x or whatever, you can put in f prime of x, and it'll draw the derivative for you. Notice it doesn't really tell you if it doesn't draw the open circles there, but it gives you the derivative. Now if I put this in and put in x squared, we get this, which is pretty much what I drew a minute ago. The colors are reversed. I'm going to change these so they're the same as what I had. Black original graph and red derivative. And if we put in a cubic graph, this is kind of cool. You can look at it and see the slope of the cubic graph is always positive, except for in the very middle where it hits 0 for a second. But the slope, it starts off, try not to zoom as I do this, but the slope over here on this side is positive. Then it gets close to 0, and then it becomes positive again. If we put in some random cubic function, x cubed minus 2x squared plus x, actually let's make that minus 3x, just to get a big swoop in there. You can see on here, everywhere where the black graph is going upward, the derivative is positive. And everywhere the black graph is going down, the derivative is negative. And we could put in some other functions. Let's put in a rational function. If you do 1 over x squared, well, 1 over x you can see, notice everywhere on that black graph, when you're going from left to right, you're always going downhill, although there's an abrupt jump there in the middle. If we change this to 1 over x squared, the black graph is going uphill here, then it's going downhill here. It makes good sense that the derivative is positive on this side and negative on this side. Change this to 1 over x squared plus 1. We get something that looks pretty much like that last example we did. All right. So again, on the test, I might give you a graph to draw, or I might give you a graph and ask you to draw the derivative of it. And if so, I'd want you to be able to locate the places where the derivative is positive, negative, undefined, and 0. That's it.